Good afternoon. In the last session, we have seen bidirectional associative memory architecture. So, in today's session, we will see the bidirectional associative memory algorithm or training algorithm. How that training algorithm or application algorithm will work. That we'll see in today's session with an algorithm. So, if you see the algorithm, in the first step, we need to initialize the weights to store a set of p vectors. P vectors is nothing but input vectors. Initialize all activations to 0. So initially all the activations, whether it is 1, 0, if it is binary activation means we have 1 and 0, right? If it is bipolar means 1, 0, minus 1. So all those activations need to be 0 at the initial stage, and we need to initialize the weights to store a set of p vectors. Initially we'll assign some weights. As a second step, for each pattern testing or for each input pattern testing, the input should follow the steps from 3rd to 8th, which are in the 3rd to 8th steps. What is 3rd step means? 3rd step is set the activation of X layer to current input pattern. So we need to set the activation of X layer to the current input pattern, means your input pattern need to be assigned to the X layer. If you treat that X layer, if you want to take it as a input layer, then you need to assign the input pattern to the X layer. Then the corresponding output will be assigned to the Y layer. For that Y layer, that output will be treated as an input layer. That's why in the 4th step, input pattern Y is presented to the Y layer. So actually here we are considering X layer as an input, Y layer as an output. That's why we are in the 3rd step we are giving the current input pattern to the X layer. And whatever the output you are receiving from the Y layer, that is output layer, will become input pattern to the Y layer, or that is in general it is output layer to the output pattern to the Y layer. Okay. In the 5th step, where activations are not converged, follow the step 6 to step 8. That means generally this bidirectional associative memory is the heterogeneous associative memory, one of the heterogeneous type. So that's why obviously you will not get input and output will not be same, or it will not be directly reach to the target output. So for that, while activations are not converged means it will not converge in the initial step itself. So we need to adjust the weights to reach the target output pattern. So for that we need to follow the step 6 to step 8. So how it will converge means, for example, your input pattern is assigned to the X layer. Then X layer need to be processed towards the Y layer, and your Y layer will give some output. That output vector is not matching with the target vector, whatever we have assigned as a target vector. If it is not matched with the target vector, then again that output need to be processed towards the X layer. Again X layer need to activate the function, and X layer will have the computational task. Again that X layer will give some output, right? That X layer output is nothing but actual input to the X layer. If X layer output is not matching with the input, then again you need to go back towards the Y layer. Then towards the Y layer, while you are processing, your weights will be updated so that you will get the new output. If new output is matching with the target output, then your activations are converged. Otherwise you need to repeat this loop process, X to Y, Y to X. While you're going from x to y and y to x, if you're going from x to y, you will get some output. That actual output need to be matched with the target output. If it is not, then again come back from y to x, because that is bidirectional associative. Bidirectional, right? On both sides you have arrows, so it can work on both directions. Both the layers, x layer as well as the y layer, is the computational layers or computational layers. So again we'll go back to from y to x. Again, while x is having some computational task, we'll get some output. That output is nothing but it should be matched with the x layer. So it is a continuous process. Still it converge. We need to continue this process. While activations are not converged, we need to follow the step 6 to step 8. What is step 6 to step 8? That we'll see. So in the step 6, the activation of Y layer and net input are computed as. What are the activations we need to use, as well as what is a net input? Net input to the Y layer is nothing but all sum of the product of the weights and corresponding inputs is nothing but the net input at the Y layer, right? So it is nothing but Y in at jth input. Let's take that sample input is J. J is varying from, J can be 1 to M or 1 to N. So Y in J is nothing but net input at jth node or jth neuron is equal to summation I Wji into Xi. Sum of the product of the weights and corresponding inputs will give the net input. And if you want to get the actual output, that is Yi, output at ith node or ith neuron is equal to function of net input at Y. That is nothing but function of Y in J. So that activation functions already we have seen in the previous session. How do you get that activation function for binary input as well as the bipolar input? So after this, send these signals to the X layer. You have done the computation task at Y layer. These signals need to be sent to the X layer. Again, X layer will perform the computational task in the 7th step. Update the activation function in X layer, which is nothing but towards the X layer also again we will get the net input at X layer, that is nothing but X in I is equal to summation J Wij into Yj. So simply that weights are weight in sum of the product of the weights and input. Here while you are processing from Y layer to X layer, your Y layer is nothing but input and X layer is nothing but output. That's why X in I, net input at the X layer. Overall output at the X layer is nothing but Xi here. Xi is nothing but function of the net input, that is nothing but function of Xi Ni, that is actually the 7th step. Xi is equal function of Xi Ni. Please correct that one. Here I have written that Xi is equal function of Yi Ni, but that is actually Xi Ni. So after this, send these signals again to the Y layer, and from Y layer to X layer, again X layer to Y layer. In this process, while you are testing for convergence in the 8th step, if you test for the convergence, if it is converged means your actual output is reached to the target output. Otherwise, you need to repeat this process. The 8th step, when you test for convergence, the stopping condition may be that the activation vectors X and Y will have equilibrium. Equilibrium means from X to Y, your input pattern is to the X, then X to Y, then Y to output, actual output, and actual output will compare with the target output. If it is matching means, then we can go back. If it is matching means we need to test it again, the same thing, whether it is with respect to the x layer or not. For that, actual output or target output, we will take it as an input to the y layer, then from y to x, then from x you will get the output. That output should be matching, it should be matched with the input pattern. So on both sides we will verify x to y as well as y to x, whether it is matching with the corresponding outputs or not. That we will test. Then we will see this algorithm with an example, numerical example in the next session. Thank you.